The assignment for this lab are as follows. First of all, create experiment responses for the average numbers of parts in the buffers between M1 and M2, between M2 and M3, and between M3 and M4. So there are three separate experiment responses for you to create. The second task is to create a status plot that shows these same values. So the average buffer contents between the M1 and M2, M2 and M3, and M3 and M4. For the third task, I give you three different configurations of the system. In this case, a configuration is defined as using the processing time distributions for the four stations. So for example, the configuration C, the processing times at M1 are uniformly distributed between 1 and 2. At M2, they're uniformly distributed between 0.5 and 2.5. At M3, the processing times are exponential with a mean of 1.5. And finally, at M4, the processing times are uniform between 1 and 2. So you should assume that you have 20 total buffer slots to distribute between the three buffers, the same three that we did in the previous two problems. And your task is to find the buffer allocation that maximizes the throughput of the line. So for example, the configuration I give, 7310, means that you have 7 buffer slots between M1 and M2, 3 buffer slots between M2 and M3, and 10 buffer slots between M3 and M4. The fourth assignment, suppose there's a 5% probability of fallout at each machine. So in other words, 5% of the parts processed at that machine are bad and immediately exit the system without proceeding to the next machine in the system. The task is to modify your model to reflect this change. And then finally, task 5, determine whether the optimal buffer configurations that you found in question 3 change as a result of the part fallout that you added in number 4. Also note that for questions 3 and 5, you should justify your choice of the replication length, the warm-up period length, and the number of replications that you've chosen to use. And so I'm not looking for an analytical result here. I'm looking for you to just justify primarily based on the small plot values that you see, the confidence interval half-widths, and so on. So the justification really just involves looking at the results and making an educated guess, and then justifying that based on the results that you see.